Okay. So we're recording, and this is test 5A, spring 2022, test 5A. This is the Zoom for 5A practice problem set 2. Okay. All right, so I'm going to share the screen. Unless you guys have anything you want to ask first while we're face to face. Yeah, John said record. I am recording though. Thank you, John. All right. Anybody got something to say about this or that? So I'm pretty much just going to look at problem set 2. Okay, 5 problems. All right. That's what I'm set up for. Okay. Share that. Okay, so I think you can see that. Hold on a minute. Let me get it so I can see everybody. And I got to redo this because I lost all my chat. Let me get the chat up there again. Okay. All right. So if you have something to say, just turn your mic on. Don't turn your camera on, but turn your mic on. Or you can chat it. I may or may not see it though. All right, so number 1, we've done this before. I wrote this obviously a few years ago when Donald and Nancy were going at each other's throats. But here we go, ice skating. And I do have a YouTube on this one, not on this particular one. It's back to the Kevin and Russ one. But this on the YouTube, it's Kevin and Russ with a ground speed of 20 meters a second. So the YouTube example is like the one in class, but remember the big difference here is Donald throws the rock with a speed relative to him of 24 meters per second. So that means that you got to add, I'll show you in a minute, it means you got to add his speed to the rock speed. So here's the first set. I have this set up in steps. Here's the first step. All I did was I draw it out, put the little arrows on there, little 3 lines meaning movement. Just so it's always kind of the same, but sometimes like on the test, it might be that he is skating away because it'll be, all right, the test Thursday, I haven't written it yet, but it'll be similar to this, but something about it will be different than the first 2 times you saw it. The first time was generic. The second time, the speed was relative to him. The third time, maybe if it's not going to be Donald and Nancy, but maybe one of them skating. Maybe one skating this way and one skating this way, rather than skating like that. If you can see my hands, my fingers. I don't know if you guys can see me, but they could be skating towards each other like they're doing here, or they could be skating away from each other, or they could be skating the same direction. So there's all these different, or maybe Nancy, if it were this thing, is not moving to begin with. Or maybe she or he throws something at the other person that thing is so heavy, it turns them around and sends them back the other way. Okay, so in that case, your signs change. It's still the basic same problem. Recoil with initial velocity and inelastic collision. Still the same basic problem with some tweaks. Okay, so here's my second step. Now I go in and I put in the numbers. All right, but notice that relative to him, the speed of the rock is 24 meters a second. But he was moving at, he was moving at 5 meters a second. So I fixed that. Hold on. This is fixed in the equations, but that should be 29. That should be 29. I changed that number, 29. So 29, so 24 plus 5. So 29 meters a second is how fast that rock's going relative to the ground. And this is called an inertial frame of reference. Everything has to be referenced to one thing that isn't moving okay, relative to everybody in the problem. You might have 7 people in the problem, but they got to reference it to one thing, okay, that's not moving. So that would be the ground. All right, step 3. I'll change that again. I know in the numbers, whoops, in the numbers I fixed it, but I'd forgotten I hadn't fixed it here. 29, 29. Okay, now I just put my general equations on there. A recoil with initial velocity and an inelastic collision. Okay, so left side, right side. Now I throw in my numbers. Hopefully I got my numbers right. Okay, there I fixed it. Well, I fixed one of them. Oops. Okay, so that's still 29. And so over here, I put the 29 meters a second. And that's about as far as I'm going to go on that. I think you can plug in numbers. That was the main thing, is to remember that it's, 29. I don't necessarily want this just to be something somebody copies off. So I'm going to leave the rest to you. And certainly if you have questions, ask them now about this problem so that somebody's watching the recording. I want them to get the questions answered now if this is all they wanted to look at. So on the other one, oh, by the way, I'll start the next one. This one for the inelastic collision will be 3, still, it's the mass of the rock, 3 kilograms times 29 meters per second. Okay, plus, and then you got to put Nancy's mass, Nancy's initial velocity. Now, one mistake students make, it's supposed to be a help video here. Here's a mistake I see all the time. The mass of Nancy is 60 kilograms and her velocity is 3 meters per second. Hoy says, do you add 24 with 5? Yes. That's where you got the 29. Thank you for that question. But what mistake did I just make?
-3.
Yes, because it has to be relative to the ground, and she's going, to the left. And so normally you make to the left negative. So that's a -3. Okay. And then you can do the rest. All right. All the number crunching. All right. So if you're cool, we're going on to number 2. Thumbs up. Give me the thumbs up. 1, 2, 3, 4, 5, 6, 7. Okay. Good. 8, 9. Okay. Number 2. We talked about in class a little bit. It's yeah. Okay, so this is the shortcut, right? We can use the shortcut here. So here we go. Number 2. So we start off with that. And then my first step, your first step, I know it seems like, and it is, it's a simple algebraic equation. And maybe it's just me, but I get this mental block. When I'm going from algebra equation to head to tail, like all of a sudden my brain shuts down, different part of my brain. And so I got to remember, I don't want to mess up which one I'm going to make negative. Now, back in first semester when we were doing head to tail, we were just adding stuff, right? No big deal. But now you got to flip things, you got to flip their sign. So it's just conservation of momentum. It's elastic collision, but we catch a break. We catch a couple of breaks. One, all the masses are the same, so I can get rid of mass. So in those cases, it is conservation of velocity. The other thing is that one of the things is a movie to begin with. So object B, which would be Mr. Patrick's glance ball, and by the way, he'll be back next week. He's dying to get back with you guys. But his glance ball wasn't moving when I hit it, so that takes away that momentum. So that's why we have this that's why we have this equation, and that's what I'm trying to solve for. I'm trying to solve for the final momentum of, or in that case, really momentum, because I don't know the velocity, I don't know the masses, it doesn't matter. I'm going to find the final velocity of my disk. So I have to know what direction it's going, and how fast it's going. Okay, step number 2. I draw it. I draw what it told me, and it said that Mr. Patrick, oh, okay, now this is the one that Ben looked at, and Ben did this. I told this is the third hour, I think. Ben did this both component method. He went above and beyond. He went component method and head to tail. And so when you do that, you find out that there's about a 5-degree error, which I hadn't even thought about. I just threw the numbers together thinking, okay, it's head to tail. But he proved that this is a slightly impossible situation, which is kind of cool. The math tells you this can't happen. It seems like it could happen. Why can't it happen? Well, apparently it can't. I don't understand. Oh, I know why. Either the velocity couldn't have, hitting it at that angle, it wouldn't have 6 meters a second. It couldn't. It's close, but it couldn't. So I've had this problem for a few years now, and he's the first one to ever try and do it by component method, which is cool. So I fixed it for next year, but anyway, so all I did here was I drew with the very carefully with the ruler, I drew and a protractor, I drew the 6 meters a second. Okay, good, keep going. Step number 3. Oh, I got a bunch of steps here. How did I just jump to all those steps? Sorry. We put a bunch of steps on there. So what I did was I put the ghosts on there. So I have this ghost, and that is simply negative B, Mr. Patrick's disk, flipped it because it says negative there. So that's the negative, that's the negative 6 meters a second. And then the resultant simply goes to the very beginning, which is where I start, to the very end, which is right here. And then I'm still not done yet. That's my resultant. If I saw that on your paper, I would give you I already have the answer here, but I'd give you an 8 out of 10 because you have the answer, you have the R, but you don't really, that's not really where it takes off from. That's the mathematical resultant. And so hopefully I added the right one at the end. Yeah, okay, so here we go. So the black here, this is the actual answer. That's going to be, and judging, realize that, okay, that's actually off by a little bit, but that's going to be what my disk is going to do. It's going to go off, it's going to glance off this way. And I'm going to be going at 7.5 meters a second. And because of the error here, and because you're measuring and then you're using a ruler and you're trying to, let's go plus or minus 1 meter a second there. And I said 76 degrees north of east, plus or minus 6 or 7 degrees. Okay. Values can be a little off. Oh, Patrick's asking something. Would subtracting the PAI be counted as wrong? No. Aren't I? Oh, yeah, it would be. Hello. Yes. Yes. Well, let's see now. You would get the opposite answer, right? Because like you're flipping everything. If you said PB final minus PA initial, you would get, your arrow would be backwards. Yeah, that's why you don't want, because so Patrick's saying instead of revert, like what if you reverse the wrong one? Yes, that would be wrong. You'd probably get, you had the mechanics, you got your algebra was wrong, right? I mean, your algebra was wrong, that's all. But that can happen really easily, that you would subtract that's why I go through this seemingly simple process just to force me, because my brain gets messed up, just to force me to do it right. Okay, it's worth those steps. And I think on the test, I'll have boxes. So kind of force you to do the steps. Okay. Question. Oh, so the answer again is right. Chia. Right here. That's my final answer. Are we good? Questions on this before we go on? We'll be out of here in no time. Got 19 of you. That's pretty good on a Tuesday night, I guess. Okay, so now we'll do the thumbs up if you're ready to go on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. All right, thank you, Samara. Number 3, this is the, once again, this time, we're doing the shortcut, but with units, with numbers. And on the reference sheet, which is up now, the reference sheets, I have all 31 reference sheets in the Facebook group, and I have PDFs of all 31 reference sheets. Will you get all 31? No. But let's go back. Oh, it's not on this file. You won't get, you're going to get a bunch of them. Tomorrow, somebody remind me in second hour. So that's my first class with you guys. Somebody in second hour, remind me to tell you which reference sheets you will get. Okay. And I'll give you a stamp. First person to remind me, you know, Patrick's going to come in. You guys got to beat Hoyt. You got to beat Patrick. He's coming in second hour. He was waiting at the door. So you got to beat him to it and remind me to tell you which reference sheets you're going to get. All right, here we go. Please tell me. Oh, yeah, I did this. Okay, here we go. So there's the problem. First thing I do is I made right triangles. Now, this is on the reference sheet, by the way. This much is on the reference sheet. So you turn those vectors. Well, how long do I make those daggone vectors? I know that A is 7 meters a second. That vector right there is 7 meters a second. Now you go, Mr. Askey, I thought you needed to include your mass. Not if the masses are the same. You don't, because they all cancel. So in this weird case, Descartes is correct, and it's conservation of velocity. Okay, it's moving along, strikes stationary disk B of the same mass at a glancing blow. After the collision, disk B moves at a speed of 2.4. See, this is something you did not have. You didn't have that on the worksheet, and that made it really hard. So when you're given that, that's that blue velocity vector's length, the hypotenuse length, which I'll get to here, that helps you a lot. It's going to make it a lot easier. And that's 70 degrees. The blue triangle comes off from the direction of motion at 70 degrees. Well, obviously, we said that these angles are complementary. So that red, this right here must be 20 degrees. Okay, because they're complementary only in this shortcut situation. Okay, let's go to the next slide. So I just said that. Now, well, I didn't just say that. These two must be congruent because this is what Gabby got mad at me about. I'm saying that all of a sudden you have momentum in the Y direction where you didn't have it to begin with, which is all legal as long as you kill it the instant you have it. Okay, so I can go up where I wasn't going up before as long as I kill it by going down. Okay, the motion has to be killed because you can't just arbitrarily manufacture motion in a direction out of nothing. Okay, so those two are congruent. It says, notice I did all that without, I didn't put any numbers in here. How did I know how long to make that red without even putting numbers? How did I know how long to make that red arrow? This red arrow, this hypotenuse. How would I know? Why isn't it half that long? Why is it that long? Anybody want to turn on the mic and answer that, or in the chat? Patrick said the Y length matches the blue length. That's true, the two links. So I took my ruler and put it on there until that, and I knew it was 20 degrees because it's a shortcut. So until that length was the same as that length, and I knew that was 70 degrees. Now I must have measured that one, you know, using a scale. I just made up a scale, make it relative to this. And by the way, this one, you don't need rulers and protractors. You can do this freehand because we're going to use trig to solve this, trig and algebra. Okay, I'm just doing it because it's the key. All right, that is what it looks like. Let's keep going. the next step, I said con velocity, this is conservation velocity, works in this special case because masses cancel. Okay. I zoom in. I want to zoom in now to the blue. And there's your 70 degrees and 20 degrees. Okay. So, and there's your 2.4 meters a second. That's relative to that 7 meters a second. Okay. Keep going. Now I zoom into the blue. Well, I did something different. Okay. So what I did on the blue now is that, now this is maybe the hardest step for some people. So I'm turning that blue hypotenuse. It's a vector. You know what it is? You know what this blue arrow is? It's a vector at an angle. And something about vectors at an angle. This is something that not many people know. Vectors at an angle, it's the hypotenuse of a right triangle. So you get a little scoop for you there. So this blue arrow is the hypotenuse of this right triangle. Now I got to find the legs of this right triangle. And so this guy goes here. That's 0.82. If that's 70 degrees, blow this up a little more. If that's 70 degrees right there, then this leg, that's the adjacent side. So this leg is 2.4 cosine 70, right? And which ends up being 0.82. If this is then 70, that's sine. So that's, I'm making negative here. Notice the negative. Negative 2.4 sine of 70, which is negative 2.26. So those are the two lengths of my right triangle, the two lengths of the components. Okay? Great. Now let's keep going. Now, if I know that that is negative 2.26 right here, then I know that that's positive 2.26. They add to 0. Okay, so now I know the angle is, I know that the angle is 20 degrees, the red angle, and I know that opposite side is 2.26. So I can use that to find the adjacent side. And that's what I'm doing here. Oh, you know what I did? I didn't do that. There's two ways of doing this. I think Carson was asking me the other night, was texting me and saying, how did you get that? How did you get that 6.18 on the key? Somehow the key was there or whatever. He saw it. He said, how'd you get that 6.18? And I got that because that's 7. And I know that these two lengths of this red right triangle, the blue right triangle, these two legs have to add up to 7. Okay. So if that's, so I'm being a little lazy here. If the blue leg is 0.82, then 7 minus 0.82 gives me 6.18. Now I could also found it by saying the tangent of 20 degrees is 2.26 over x, and then solve for x. That would have given me 6.18. Okay, either way, it gives me the same answer. With maybe a slight round off here or there. Okay, so far so good. I suppose you can give me a thumbs down if you want me to slow down or something. I don't know what all your little icons are. Okay. Okay.
Is there a formula? Is there a formula you're using to solve that? How are you solving it?
Solving which one?
Number 3.
I know, but which part?
Well, I know how you got all the numbers. You just do the sines and the cosines to find the legs and stuff.
Yeah.
Because
are you wondering about the 6.18?
Yeah.
Well, I knew from conservation of momentum that the or velocity in this weird case, but conservation of velocity here, it says that the velocity at the end of the collision has to be in the x direction, has to be the same as the velocity was before the collision. So the velocity before the collision was 7 meters a second. So the combined velocities or x components of those velocities has to still equal 7.
Got it.
Yeah. And since that's 0.82, I just subtracted that from 7. That's the cheap man's way of doing it. The more sophisticated way would be to do cosine or tangent. Do tangent of 20 degrees equals 2.26 over what? And then you'll get 6.18. You should. I didn't do it, but you should. I have confidence in Tree. Now we got to finish this daggone thing. And by the way, this is the shortcut version. I got to finish it. And so I got 6.58 there because I just did Pythagorean theorem. Okay. And I just lay, you know that one. And then I got to find the angle, and I used inverse tangent of the y over the x. So 2.26 over 6.18. And it's, yeah, after I did that, I go, I already knew it was 20 degrees, but it was a good verification. So it's 20 degrees to 2 siggies anyway. Okay, done. Questions? Okay, so let's go thumbs up for to go on. 1, 2, 3. Max, not your index finger. It's your thumb you put up. Oh, okay, there you go. All right, we're good. We're good. Number 4. This one should be fairly easy. There's no numbers. There's no calculator required. So once again, glance ball. Oh my goodness, I just realized they give you 3. Yeah, I get, oh, no. Oh, I don't know if this is advanced glance ball or so. I don't know if the shortcut works. It doesn't matter. It's worked the same way, but we cannot say conservation of velocity here because I was not given because there's 2 kinds of glance ball. There's the AP physics where they don't weigh the same, and then it's regular physics where they do. So let's don't assume anything, but we don't need to. So I've got to go in here and once again, do the equations. Okay. So, it's right here. So here we go. First, do the equations. Just use conservation of momentum, PAI plus PBI, PAF plus PBF. And then there's nothing that'll cancel this time. So I just got to end up with what I'm trying to find, which is PBF. I'm trying to find the final momentum of block B or of disk B. So simple algebra says I subtract PAF. Okay. So I'm going to add the 2. I'm going to add the PAI and the PBI vectors. I'm going to subtract the PAF vector, and then I'll give them my answer. So I have a couple of ghosts. I do my ghosts in green this year. So all I did was I took PBI right here. I took PBI. I moved it because I'm going to go PAI to PBI to negative PAF. So I slid PBI up here so it's head to tail. Then I took PAF and I flipped it and I moved it over here. So that's negative PAF. Okay. Then my resultant will go from my very beginning, which is right here, to my very end. Voila. Yeah, baby. And if I had that, if I left it like that, I would, once again, you get an 8 out of 10. Okay, pretty good, but you didn't finish. That's the mathematical resultant, but now we got to slide it into place where it belongs. And it belongs right there. So that means that now you got to look at it. You always want to go back and look at it and go, wait, does this make sense? So I don't think this is not regular glance ball. This is advanced glance ball, because PAI comes in, hits, bounces off this way. PBI comes in and bounces not straight back, but bounces way back. So either PBI, it could be regular glance ball, I suppose, if PBI is going slow and PAI is going fast. Something still seems weird about it. Anyway, you know why I know it's no. You tell me for the bonus, for the 2 extra stamps, how do I know this? How do I know their masses were not the same? Or how do I know this is not the shortcut situation? What's proof positive? Thank you. Patrick's like kicking butt here. All right, so no, he's not. He's wrong. He's wrong. He's wrong. He jumped in there. He had the Kutz. Oh, keep going. He's got another idea, but perhaps Carson jumps in, or Ren, maybe Greta, or Lynn, or Leah, maybe Evan. How do I know this is not a shortcut situation? It can't be. Proof positive. Think of the rules. PBI was moving. Jackson, he found it really quick, but okay, I'm gonna give Jackson 2 stamps because he said to be shortcut situation, one of them can't be moving. And then there's another reason though. And John was saying the same thing. And okay, Jackson said it first, he gets 2. Sarah gets 1, Hoy gets 1, and John gets 1. But there's another reason why I know it's not a shortcut.
The angles have 90.
Right, there it is. And that's what Cole said it real quick. So the angles here, the other reason is obviously not, is that these two are supposed to be complementary. This PAF and PBF should add up to a 90-degree angle. Okay, good job, guys. That's it for that one. All right, we got one more. You know what? I don't know. You know what? Okay, I'm going to give you guys a break because I didn't do this one. You know why? Because it's on the exact same problem is on YouTube. And here's the link. I'll put the link. It's not that long of a URL. You can type that in. I'll put the link in the comments when I put this on the Facebook group. I'll put the link there, but if you want to see it before that, just type this in. So I'm not going to go over, I'm not going to bore you with all the steps. I've already bored you on YouTube, and this has already been worked, the exact same problem. So yeah, so I'll leave YouTube for that one. It's a good one, by the way, and do not blow it off because that one, it's been on the test the last couple of years. So a good chance something similar will be on the test. Okay, what else we got? We're not going to do that one yet. We'll do it. We'll get to that Monday or Friday. We'll probably get to this Friday. We'll get to this Friday. We'll get to the other one Friday too, I'm guessing. Okay. Tomorrow we're doing the duck walk. All right. Who's got a question before we adjourn? We got out of here in 24 minutes early.
Can you
This way from now on. Question. Oh, Patrick said, oh, the wrong word. That's what I thought Patrick meant complementary, and he said congruent. Okay. Question.
Can you talk about how to do a component method with the and the stacking and racking? Just like how to approach the problems.
Hold on. The only one in here that would be stacking and racking. I kind of just did it without stacking and racking, but this is the closest thing I have. It's already queued up. So that's a good question. If I have, so like in this case, okay. If I'm solving for, so the stack and rack is like we've always done with iRoof, JRoof, only I think I do stack and rack on the one on YouTube, but stack and rack, you do it the same way, only you have to be careful because like in this case, we have, I'm not going to put colors or anything, but we have PAI plus 0 because PBI isn't moving equals PAF plus PBF, and we're supposed to solve for actually both. Oops. Oh no, I know PB. I know if the blue is B. Okay, so I know PBF. So I'm trying to solve. So I say PAI minus PBF equals PAF. Then for the stack and rack, if I say I was going through the whole process, I would have PAI here and minus, or the opposite of, PBF here. I'm stacking those two. My answer is going to be PAF. And so I would have something I roof, hold on, plus something J roof. And I can tell you what those actual numbers are. PAI is, I'd have 7. I'm not going to put units, 7 I roof plus 0 J roof. And then for PBF, I would have, for the I roof, I would have 0.82 I roof. And then for J roof, I'd have negative 2.26, negative 2.26. But I'm subtracting them. See, that's the difference. That's the complication here, where we didn't have first semester when we were doing stack and rack. Sometimes it's stack and subtract. So when I subtract these, I got to make it negative. That's got to be positive now. And then I'm adding the opposite, right? You're adding the opposite. So that's going to end up being 6.18, which I got I roof plus 2.26 J roof. And that's going to be my red. That's what I end up with. That's what I end up with up here, that red triangle. And then from there, I could plot it. I could draw it. So that's using, and I think I do it again in the sample problem number 5. I do a stack and rack area. Okay.
I have a why do you only, never mind.
No, Cole, you asked a very good question. Just go ahead and throw it out there.
Well, I just saw that the 6.58 is a different number than 6.18.
Because Pythagorean theorem, right? I have to.
Yes. One of the hypotenuse. Yeah, I didn't
Yes,
see that.
And that's you also do that in stack and rack. When you're done with the components, you do Pythagorean theorem, then you do inverse tangent, and that's where you would get that answer. Yeah, that's what we did, inverse tangent. We did Pythagorean theorem. I just didn't show it, like maybe I should have, in a stack and rack situation. I was more just going off my figure. Okay. Other questions? Okay. Well, you guys can go, and if you want to stick around, ask a question, I'll be here, and I will turn off the recording, so you can ask your question in private if you wish. Where's the recording button? Why do I always forget this? I'm just going to hit the stop share, then it'll come up. Okay.
Mr. Maskey.
We're going to pause.